All right, everybody, welcome to the video here for lesson number 3 on adding and subtracting rational expressions. So just like adding and subtracting fractions, which you learned back in middle school or elementary school, to add and subtract rational expressions, you just need to make a common denominator. So for example, for this first question, our common denominator is going to be 8. The second fraction already has the common denominator of 8, so now I'm thinking, well, what do I have to multiply that first fraction's numerator by to make it so that the denominator would also be 8? And that would be 4. So I would make that 8 plus 4x. Now that I have a common denominator, I can add across my numerators. So if I combine my like terms, I get 5x plus 8 all over 8. No variables in the denominator, so no need to think about or look for undefined values. For part B, our common denominator here is going to be 6y. So the second fraction is already set up for us. And we're just worried about changing the last one and the first one. So for the first one, I have to multiply by 3. So that would make the numerator 9x. And for the last one, I have to multiply by 2. So that would make the numerator 2x. So if you do some quick calculations here, so 9 minus 5 plus 2, so that's going to be 6. So that's going to give you 6x over 6y. And those 6's are going to reduce, so I'm just left with x over y. Now notice there's a variable in the denominator, so I also have to think about an undefined value. So y, well, it can't be 0. For part C, I noticed that these two denominators look very similar, but they're not the same. So I'm going to make them x minus 4, making that first fraction stay the same. But to make the second one x minus 4, notice it's an additive inverse, right? So if I multiply the top by -2, well, I've just really essentially multiplied the bottom by -1. So if we go through and combine our like terms now, I have 1 over x minus 4, where x cannot be 4. So as soon as I see this situation where I have two things that would add up to nothing, just multiply one of them by -1, and that's what we're doing here. For the next one, my least common denominator is a squared. Add up what you got. So I got 2a minus b all over a squared, and a can't be 0. That one was an easy one. For E, we have that situation again where we have two things that would reduce to -1. So let's just multiply one of them by -1. So I have 8x over 3y minus 2x plus -12y over 3y minus 2x. Add up what you got. So I have 8x minus 12y. Those are not like terms, so they can't be combined. And then look to factor, right? In the numerator, I see a GCF of 4. That gives me 2x minus 3y. In the denominator, I have 3y minus 2x. These two are additive inverses, so they become -1 when they reduce. So my final answer here is -4, where y cannot equal 2x over 3. Where am I getting 2x over 3? I'm taking this denominator and setting it equal to 0. And solving for y. If you solve for x, it's going to be a different fraction, but it totally works too, right? It really doesn't matter either way. I just chose to solve for y because I thought it'd be a little bit easier. The next one's kind of like a trick question. Notice these look like the last example or even the example in part C because they are backwards of each other, but they're actually not additive inverses because it's addition. They're actually the same. So this is just going to be the answer 1 minus b over b plus 1. I'm just going to be able to combine across right away. B can't be -1 because that's an undefined value, and we're all set. For G, I have this additive inverse thing again. Notice that's come up a bunch here, so that must be important. So this is going to become -3 up top So now I'm going to have 3n minus 3 all over n minus 2. Even if I factor the numerator, I notice nothing's going to reduce in the denominator, so it's unnecessary step at that point. If you did, it's totally fine, and there's your answer. For h, we have to factor this first denominator, so I'm going to get b squared plus 1 all over b plus 2, b minus 2, meaning that second fraction also has to have b plus 2, b minus 2. And it already has b plus 2, so I'm going to put a b minus 2 in the numerator. For that third fraction, I also need to have b plus 2, b minus 2. But it already has b minus 2, so I'm going to just put in b plus 2 in the numerator. Combined up your like terms, so b squared has nothing to combine with. B plus b is 2b. 1 and minus 2 and plus 2 is just plus 1. All over b plus 2, b minus 2. Again, the numerator is factorable, but not factorable to anything that would reduce with b plus 2 or b minus 2. So it's an unnecessary step. If you did it, it's totally fine. And the last one, a challenge question. So it says, write as a single rational expression in simplest form. So to do this, we have to do some factoring. So the first numerator is going to stay the same for now. The denominator is going to become x plus 2, x squared plus, not plus, same opposite, minus 2x plus 4. The second fraction already has the x squared minus 2x plus 4, so I just have to include the x plus 2. So if I multiply out that second numerator, right, that second numerator is going to multiply out if I make my boxes and do that whole thing. It's going to become x squared minus 2x minus 8. And then see, this subtraction sign tells me to distribute the subtraction to all of this. So that tells me that when I get this new bigger fraction, I'm going to have a 2x squared minus 1x squared, which is x squared. I'm going to have negative 4x minus negative 2x. Well, that's going to become a positive, so that's negative 2x when I combine those up. Negative 4 minus negative 8, again, the double negative situation there, so that's going to become a plus 4. And that's all going to be divided by x plus 2, x squared minus 2x plus 4. Notice the numerator reduces with that one value. So my final answer is 1 over x plus 2. And then if you were looking for those undefined values, one of them is really easy. X cannot be negative 2. The other one, not so much. So if I have x squared minus 2x plus 4, not factorable. So that means I would have to actually do the quadratic formula there. So I'd have 2 plus or minus 4 minus 4 times 1 times 4, all divided by 2. And you're going to wind up seeing something here that happens that we don't like. So this is going to become the square root of negative 12 over 2, which gives us an imaginary solution, which is something that we're going to talk about later on in the next chapter. For right now, let's just say we're just going to look for real undefined values. So we'll just leave it at that. Hopefully this video helped. Again, I will be posting another one here in a couple minutes on the next lesson as well. So make sure you check both solutions. Good luck with your homework.